cheap solar power, batteries, and electric vehicles are changing the transport and energy sector as we know. I bring in guests to this podcast who will help you with their ideas to navigate this energy transition. Thank you for joining. Hi, Jaap. It's finally great to be connected. I like your really nice background. Yeah, maybe you introduce yourself, what you've been doing. I know a lot of exciting stuff on the charging.
Thank you. So thanks for having me. It's a pleasure being here. So a bit about me. I work on e-mobility, smart charging, vehicle to grid, consumer energy, like flexible heat pumps, like the heat pump you might see in my background. So I've been doing this for more than a decade now for various organizations, private, public organizations, and the past 5 years mainly for Regulatory Assistance Project, which is a global NGO group of energy experts. So we work to accelerate the energy transition, to make sure that it's more equitable, to make sure that we decarbonize at the fastest and efficient way possible. So my focus is on Europe. So I work mainly from Brussels. So I focus on European member states, the policies on electric vehicles, EV charging, consumer flexibility.
Okay. So which country has the best EV incentives, you reckon? I had someone discussing the Norway one last week, but yeah, which one you have?
Obviously, Norway is great and interesting, and it's partly maybe not because EVs are incentivized directly via subsidies, but they pay, at least the past decades, had to pay not pay certain taxes that petrol and diesel cars had to pay. So relatively, they were much more affordable and attractive compared to their internal combustion engine counterparts. And that's interesting because most countries would think, and people would think, you need to incentivize electric vehicles by grants and subsidies. But the key is the relative cost compared to their fossil counterparts. So you can do it, if you design it well, you could do it in a budget neutral way for the government. So Norway is interesting. I see many of those Scandinavian countries. Denmark is another example. So lots of private households buy electric vehicles there. Not only new ones, but also used ones. So they import them from other countries. And obviously running costs are so much better with an EV, especially in those countries that have already lots of renewables on the grid. So it makes total sense to switch to.
Yes, absolutely. And Norway, the other thing that I found interesting is, and which it should be, that electric vehicle meant true electric vehicle. Hybrids are not electric vehicle. In many other jurisdictions in Asia, especially in the Philippines, they are counted as the same. So what about in other part of Europe?
It's still part of the discussion in Europe, also on the European Union level. In countries like Germany, they really, pushed by some of their car makers, want to extend this definition of electric vehicles to definitely also in the future to include plug-in hybrid vehicles or extended range electric vehicles that in the end for consumers are not the most affordable solution. So you end up with basically two drivetrains that need maintenance. So you have costs. In the end, you would still be dependent on a lot of the current infrastructure in place for refueling. Plus, in addition, you would still obviously need the charging that you also want for pure electric vehicles.
Yeah. Of course, I think you will agree that the fossil fuel industry has a lot to do with that as well. So you have the infrastructure,
Right.
you want to let it go.
And that might be understandable if you look at the horizon involved with the investment in that infrastructure. But it's inevitable that we transition away from that type of infrastructure as well. Switching to electric vehicles is a huge energy saving. The amount of energy saved by using an electric motor for propulsion is, I mean, we're talking about only a third of the energy compared to burning fuels and then using that those explosions to turn that into motion, that's a hugely inefficient process. And by making that switch, we also switch to a totally different mental model of getting energy into the vehicle. So no longer passing by a gas station, refueling your car, but now it becomes almost an action that doesn't take any time. You get home or you arrive at the workplace, plug in, or maybe not even plug in with wireless charging or robotic charging, but you park the vehicle and charging takes place whilst you're doing other things like work, sleep, eat.
Yeah, I was telling the other day that if we had mobile phones, that we had to go back to the phone companies once a week to get it charged, people will just go bananas. But that's what we have been doing with our internal combustion engine cars.
Yeah. Yeah, that's a great comparison. Right. That's basically the model that people that haven't switched to an electric car are still in. And it's sometimes hard for them to understand how that different world will be. But maybe using this mobile phone as an example will help them understand what the transition will be like.
Yes, absolutely. Because the other aspect is, which I'm sure you appreciate, but the average person don't. I have a thermal camera. So once I took a photo on a street on a sort of nice, cool evening in Thailand.
Mhm.
And basically, you see blue. Basically, this is the air conditioned car inside. And then the
Yeah.
front part is glowing orange or yellowish, very bright, because that's the heat is. And then once a car stopped, I actually took a temperature. So it was 400 degrees centigrade. So just imagine you're
Wow.
sitting in front of 200 cars on a highway, all
Yeah.
carrying a humongous size heater, and not at a domestic setting of 60 degrees or sorry, 26 degrees. It's set at 400 degrees. And then it's, oh, I wonder why the cities feel so hot.
Yeah. No, but it's true. And I read this academic paper once that tried to quantify the effect of combustion engines on urban heat. So the heat effect in cities. And for most cities, I think they took Chinese cities as an example. So it amounted to 1.5 or 2 degrees Celsius that just the combustion in those vehicles added to the already existing heat waves in cities. So that's huge. And if you think about all the health impact of that.
Yes, absolutely. But you must be electric vehicle, solar panel used to be nice to have, right? And now gradually it's almost becoming, oh, you don't have one situation. And in that switch, a lot of other things have come up. One of your area of expertise, the vehicle to grid. It was initially, it was like a absolutely theoretical interest, but it looks like a very serious, viable power station. No, what's your thoughts?
And I think maybe only 5 years ago, it was still, there were pilots and trials with vehicle to grid technology, and it was like an interesting promise. And now today we're no longer on the brink, I would say. So we've passed that sort of moment where it was like the technology of the future because it's here already. There are vehicles that you can buy that support bi-directional charging, and you see the first commercial offers with energy suppliers being made available. And I think as of next year, if you look at the announcements of car manufacturers, more and more vehicles will support it. And you also see on the charging hardware side, the charging hardware supports it. And now we're slowly trying to adjust energy system regulation to this new reality that all of a sudden those vehicles become something new, not just a consumer of electricity, but also in the logic of the energy system, a generator. So meaning they can feed back, especially during peak times. So they start pushing out during peak times for the energy system. They start pushing out gas peaker plants, ultimately also maybe coal as baseload. So it really starts to help decarbonize the power system.
Yes, I'm just thinking now that many of the older charge stations were sort of unidirectional, right?
Yeah.
And there must be a way to retrofit inverter so that it becomes bidirectional. That itself would be an interesting market, no?
Yeah. Especially if you already have the DC chargers that already have lots of those components. I'm not technical enough to know whether you could just retrofit how much you would need to change to existing chargers, but I reckon that especially if you look at the deployment scale of solar inverters, but also hybrid inverters that can do solar and stationary batteries, that scale now extends to EV charging. So you get basically the benefits of the cost reduction of those products. And now bidirectional EV charging just is another action offered by these devices that have already seen sort of cost going down steeply over the past 15, 20 years.
Yes, especially if you can, like I saw Tesla recently launched a plug that you can connect and use it as a V2L, right? So I have not tried yet, but I want to get one of those plug and connect another car to see whether it can charge as a sort of level 1 charger.
Yeah. Yeah, I mean that's a nice example, and I think and it's happening. I think even more exciting would be the option, and I haven't seen that. So it would be interesting if you would do direct DC power from one vehicle to the other one. So basically
Yep.
the batteries just talking directly to each other. I think that would be a very interesting next step also in terms obviously of efficiency, because every time you do this AC DC conversion, you lose a bit of energy. So the fewer conversion steps.
Those who had really range anxiety, you can almost run a cable from another car and keep driving. So rather than waiting.
So this concept, I think, maybe not directly from one vehicle to another, but via the charging infrastructure. It really is something considered for commercial fleets. So think about distribution fleets that carry goods into the city, for instance. So they do their predictable routes, get back to the depot, and you might not need the remaining battery capacity of that vehicle, whereas other vehicles that have just arrived might need an extra boost. So you could transfer some of that capacity that is stored in other vehicles to the ones that need it without exceeding maybe the capacity of your grid connection. So you could actually give those vehicles that need the extra charge a boost from the other ones using bidirectional charging.
Yes. Even at the policy level, I can see people are having a lot of fun with these ideas, no, tossing around.
And for policymakers, it's also interesting, I would say, vehicle to grid, because all of a sudden people maybe working on energy policy get to work on vehicles. So previously, their world was defined by power stations, substations, maybe not so much consumer technology, a bit like smart meters. But now all of a sudden you get all these interesting vehicles with lots of emotional marketing around it. A vehicle is much more emotional maybe than a power station. So people also have strong feelings and opinions about them. So I think for policymakers, it's interesting to work on vehicle to grid, because all of a sudden you get to extend that domain. And for those working on previously only on vehicle policy, now all of a sudden they need crash courses on the energy system.
Yep. The energy sector was so dominated by supply side people, demand side people almost non-existent. And every regulatory regime had theoretical demand bid options, but that never materialized, right? Because demand aggregation is hard work, and how do you incentivize blah, blah, blah. Now we are in a very different place, right?
Yeah. And a very different place, and also a very different pace as well. So previously, network planning was a lengthy 30-year time horizon, maybe 10-year network development planning. But now, and staying with vehicle to grid. And so that specific demand flexibility, which also crosses the borders between demand and supply. So it's a bit of distributed generation. It doesn't fit the existing categories, so that's novel. But especially the pace in which this technology becomes available is really something unseen previously. So no longer 10, 20, 30 years horizon, but all of a sudden, in most countries, we're reaching 0.5% of vehicles in the fleet that might be capable of vehicle to grid by the end of next year in most European countries. And that might sound small, but we're talking megawatt size that all of a sudden becomes available. And then the year after that, the number might double or triple. So that's a gigantic change to how the system was planned. And all of a sudden, the system is different from what it was planned for, which, as you described very well, it used to be top down. We have generation that then matches the demand that is just a given. And all of a sudden, this demand becomes a flexible shape.
Yes. Even the generation, one can visualize if you have a truck, now the school bus, which can definitely give maybe, I think, 400 kilowatt output as a max if you want to release. And you take 100 of those, that's a 30 megawatt power station. To mobilize 100 school bus from one substation to another distress substation for whatever reason is, it's not a big deal. But just imagine mobilizing a 30 megawatt power station. That's a 3-year project.
Yes.
If at all possible, right?
If at all, yeah. Yeah, and with declining battery, the solution to many grid problems or insufficient generation in certain locations might in the future be just move a couple of trucks in that direction and connect them there.
Yeah, and if you have a train, that may be gigawatt scale. If you have a train on a line, you can move around. Now, I have a specific question. I'm just thinking now. I don't know whether you're up to date. Australian government just announced, I think, a couple of weeks back, that to tackle the duck curve problem, government is going to give electricity for free for 3 hours from next July, which it has a lot of reactions. People get mad, of course. But I was just thinking, it's actually just an off-peak tariff with off-peak price being zero. And maybe eventually it could be even negative, because this is only one way you can suck in all the excess sun that is sitting there and move from shoulder side all the evening demand, which are discretionary, in the middle of the day, so that your load profile is much flatter. No, you on that?
I think it's a perfect example of making the needed shift clear and understandable for many more consumers. So it's not difficult to understand what it means. Free electricity is free. No one dislikes getting something for free. So it helps people to understand we have a fundamentally shifted energy system. I reckon in Australia even a bit more than in Europe, but in Europe it's happening as well, that previously the cheapest hours were nighttime, and now it definitely is, at least during the sunnier months, it's the afternoon. But we need to get people used to this new world, a new idea. And what I like about making it as simple as possible, but also making it available to many more consumers, even those without solar, because people that have rooftop solar already benefited basically from that investment, and they were increasingly trying to optimize self-consumption, whether with an EV or with airco pre-cooling the house, or making hot water during the afternoon, or getting a home battery and store that energy. But now we're extending that to basically every household, whether they have solar on their rooftop or not, whether they have an EV or a battery or not. That's no longer a necessity. So we're extending it to much more users and consumers and extend those benefits of the transition to them. And I think that's a really vital point, that we need to make sure that this transition to renewable energy sources like solar, which are obviously a much cheaper and most of all also cleaner energy source, we need to extend the benefits of that even to those that don't have the opportunity to invest in their own generation.
Yeah, you have to look at the problem from the system's perspective, right? So from the system perspective, I used to work in system planning as a junior engineer, late 80s, and you come back from that, you struggle to improve the load factor a little bit because, or the load duration curve, right? You have a power station only running for X number of hours in the year, but you have to keep it there and it's very expensive when it runs. And then you have the value of lost load scenario. If suddenly a power shuts down, how do you incentivize the market to make sure somebody is putting power in? All you do is saying, hey, I'll give you free, and then suddenly that load you're worrying is vanished. It's extraordinary, no?
Yeah, and we need very advanced rates, dynamic electricity rates, highly dynamic flexibility controls. So we definitely need lots of that, especially also with connected devices like electric vehicles. But we also need something that is really easy and understandable for the majority of people to also be able to make that transition and shift. So there's never a single golden solution for energy problems, but we need all of them. And I think having something that is as simple as this really helps, and really helps also enable the more advanced solutions.
Yeah, and then the word free is so powerful. And I was also thinking, say, in a scenario, you and I are neighbors, we both maximizing the free 3 hour window by, say, heating the room or cooling the room, whatever the season is. Then obviously, if you can have a cooled living room until 7 p.m. at night, and I lose all my cooling by 6, and I'll say, why? Then you'll say, I have better insulation. Okay. You make people aware of those issues that we engineers try to tell, oh, you need to have better insulation. Oh, no, it costs money. But then suddenly you have a free resource that you're trying to contain or maximize. And then say, hey, it leaks. Why? Okay.
Yeah.
I think it's free if it is implemented. This would open up a lot of interesting awareness and a lot of interesting ideas from consumer behavior that we haven't thought of.
Yeah, that's a great point you mentioned about building envelopes, how and energy efficiency. And I think energy efficiency is interesting because it used to be a sort of minimizing the amount of energy we need, so generate less. But now it's also shifting to enabling flexibility. So if you live in a well-insulated building, you can keep that free cold in your home for longer. And obviously in some of Northern European countries, it's the other way around. You want to keep the free heat in for much longer. So energy efficiency still is important. It takes a new role. So previously it used to be to ensure we reduce overall generation need, but now it's to increase flexibility and shift
truly
potential.
optimizing. If you have an asset that has, I don't know, 10,000 or 20,000 hour life, saving that life doesn't matter much, but the issue is how much can I use it? It matters because then my capital cost comes down significantly per use. So yeah, if we can optimize, it's quite extraordinary.
Yes. And I think that's also for policymakers, something that they should continue to work on energy efficiency. So even when we, in the long run, talk about energy becoming overall electricity becoming cheaper. And I mean, we just discussed free electricity during certain hours of the day, but also overall electricity will become cheaper over time. That's at least what we expect. But then the question still remains, how can we really drive down costs for consumers or small businesses? And I think the key is not so much in getting overall electricity prices down. That's important, but it's especially enabling access to those time windows where electricity is especially cheap and abundant, like with the solar hours. So that means, how do we enable everyone to be flexible in their electricity consumption, being able to shift big loads to those solar hours or times with lots of wind. So it's no longer about just being able to consume less, but especially consume less and during the hours that are the most beneficial for both the power system as well as the user.
I see a world that our load factors becomes almost 100% because batteries are everywhere. And if the demand is able to move, like I'm in front of a fan, which has a built-in battery, or our computer's built-in battery, so many gadgets around here, everything has a built-in battery. So if I switch them on, it doesn't go back to the grid. It flat loads. So eventually car has a battery. I don't see any reason why all our fridges and air conditioners don't have batteries. As the battery becomes, I don't know, $10 a kilowatt hour one day. I don't know how.
Yeah. I was just reading about this. There's a company in the United States that builds induction stoves with a built-in battery.
Yes, I read about that.
And so they won a big project to retrofit social housing. So replace existing gas hubs with this induction stove with a battery. Because of the battery, you don't need to change all the wiring in the building, which is a huge cost. You just replace it. But from a power system perspective, it's also interesting because normally you would use cooking takes place during mostly peak demand hours. But now all of a sudden, because of the built-in battery, you don't have to consume electricity from the grid during those hours.
Yeah, this company needs to come to Australia, or if they are already, they should start promoting top up your battery where electricity is free. That's what eventually everybody wins, right?
Yeah. I find it fascinating because at first when I heard about it 3-4 years ago, I thought, that's a weird device to add a battery to, because I would think every kitchen already has electricity is something available in every kitchen. But then I learned there was also my European perspective where it's much more common to have, I mean, we have 230-volt electricity system in Europe, and in many Northern European countries, the residential household have 3-phase electricity supply. So it's much more feasible to connect an induction stove, high power induction stove, in a kitchen. Whereas United States, you might only have 110 volts plus much older wiring. And if you think about it, all the amount of work that is needed just for 20 minutes per day used for it almost becomes a no-brainer.
Yeah, if an induction cooktop with 3 burner or an oven, you're looking at least 6 kilowatts. So that's quite a significant amount. Peter Kilby, who was a guest on my podcast last year, and he was saying that he goes camping and he has one of those battery powered induction cooktop. He said, yeah, it works perfectly. You juice it up slowly. And I think he uses V2L or something. And then when you release, of course, it has a 3C release, so 3 times the capacity. And he said, yeah, you cook. And exactly as you mentioned, 20 minutes, all you need, right?
Yeah. I mean, my induction hub has the interesting, at least I like it, that it tells me after, when I switch it off, how much kilowatt hour I used. For most of the time, it's something like 0.48 kilowatt hours, or maybe 0.7 kilowatt hours if I really did some extensive cooking for pots, and maybe over an hour. So it really isn't that much. Peak power, it might be 6 kilowatt peak power if you're using power boost to boil water. But after that, it's much more gentle. And so over the time, so I might be half an hour in the kitchen, but then in the end, I've consumed not even half a kilowatt hour.
If induction cooktop is like an electric car, it heats what is needed. It doesn't heat up everything else. Internal combustion engine car or an incandescent light bulb heats up everything. And a portion of that energy goes to what is the intended purpose.
Yeah.
Yeah, so quite amazing. So what's the interesting policy work are you working in the European Union?
Mostly on making sure consumers can participate in all energy markets and provide services to the grid with any consumer energy device they have. So whether that's an EV or heat pump or hot water tank, solar PV inverters are becoming smart and connected as well in a way that you could smartly curtail some of that or limit some of the generation. So what I mostly try to advance is how consumers in all those 27 European countries can benefit not just from electrification, so switching to an electric car or electric heating or electric cooling, but also from the contribution these new devices can make to the energy system. So these devices can contribute to a more resilient system. They can contribute to a cleaner power system, especially as we discussed, shifting to the times when we have abundant solar. That's really vital. But there are still barriers in the way. So sometimes utilities don't offer rates to consumers that enable benefits from shifting in time. So rates that are flat or limitations on exports. So you might technically be able to discharge your electric vehicle, do bi-directional charging. The remuneration you get from feeding energy back into the grid isn't that interesting. Whereas it might be on the wholesale power market, but you as consumer might not be able to access that. So the interesting bit is there are many innovative energy suppliers that challenge that existing system. So they build propositions that enable consumers to participate and especially to benefit. But we're also seeing like novel forms like energy communities. So more like you and your neighbors together start acting as a utility almost, but you're no longer just only at the far end as a consumer, but suddenly you're in the middle. You're the one that is controlling and benefiting also from the flexibility that you bring and the investment that you make into new generation or new.
Yeah, you also need that for those early adopters to participate into the market. So what motivations they have. Yeah. But how do you communicate all that? How do you bring people together? Because what we are discussing, it's quite nerdy by average standard because vehicle to G. I remember last time I was talking to somebody here and he said, I heard B2B. What's a V2G? And it's not uncommon because people, these are new sort of nomenclature that came into the field maybe in the last 5-10 years.
Yeah.
It may be shorter. How do you bring people together? Do you have a large communication platform plan with these policies?
Our key audiences are policymakers and energy regulators. And so we work with most of them also directly. So some of the communication that we do also via our channels that's visible and it's visible for everyone, but we obviously also talk to them directly on some of those issues. And I think it's what is interesting in the wider system of policymakers, organizations, commercial organizations, non-profit organizations, that all of them help and support messages around the benefits of electrification, the benefits of flexibility, and sticking to the car and vehicle to grid, V2G. Not many people might know what V2G stands for, but if you talk to people that have rooftop solar, almost everyone understands or wants to use their own electricity
For their cars.
even during the evening and the nighttime. So they're looking for ways to store that energy. So that's why obviously home batteries are appealing to many houses. But the prospect of your car that is there, that stands in front of your house to use that's the concept that so many people intuitively understand. And yes, let's use that battery that's there. at least 60 kilowatt hours, but maybe even up to 100 kilowatt hours. Why can't I use that? So now all of a sudden also car makers are becoming part of the messengers around energy flexibility. So it's more like an orchestra of all different voices all together. They are helping to basically educate people. Although I dislike the word educate because it assumes that people are unaware, and I think many people are aware of the benefits. But
No,
it's
but
like everyone is doing their part in there.
educate may be actually the appropriate word because so much misinformation and disinformation going around. Educate might mean that I know it all and I actually took the trouble of going to the source and talk to some credible people to validate that this is correct. And that's why I think educate may be a very important, because you might have the information, but in this world of AI and people's motivation to misguide you, it's very
Yeah.
important to go to the credible source and verify and say, yep, that is correct, unless you go back to fundamental base level first principle saying, okay, how does it stack up?
Yeah. Yeah. Indeed. Yeah.
Wow, amazing. What else you do for fun when you are not thinking about electric vehicle and regulation and policy?
Gardening.
What you grow,
Yeah.
flowers or
Yeah.
fruit?
Both, and vegetables. And in Europe, winter is approaching. So it's kale that is still growing. So that's winter. We had apple harvest. So it's now late autumn. So the growing season ends. So it also starts.
No hydroponics, solar powered.
No, oh, that would be fun. Yeah, maybe next year. So next year's project is I do gardening in a community garden. So it's really nice with neighbors together. And starting January, we start the year new. So we make a plan. What are we going to do this year? And it's always great to follow the seasons there and think about, okay, so last year we did this on this spot. Now we need to do something different there. What went well? What went wrong? How can we store water? We have, especially winter, might be very wet, so we have lots of rain. And then maybe June, July might be very dry. So how can we store some of that water? It's not electricity, but it feels a bit like applying the same ideas of we have times when there's abundance and we have times when we have shortage. How can we bridge those moments?
If you are gardening, then you are very much aware of what nature provides us and when. I met this startup person, I think his name is Ilkham Sadikov in Uzbekistan. So he wanted to show me that I have a solar thermal for tomato plantation. So I said, seriously, how does that work? So then he took us, it's basically solar thermal. He's
Yeah.
collecting heat and then he runs his extensive pipes and inside a greenhouse and these pipes going and all of the against those pipes are tomato plants sort of
Yeah.
getting the heat, and then he had something underneath also that the roots get the heat, and he's growing tomatoes around the year when it's snowing outside. And I said, hey, this
Yeah.
is, and he's saying, I don't know, it's commercial and I love tomato. He said he was so passionate about his garden.
Yeah, and I can understand, and especially something that you've grown yourself, it always tastes better.
In your mind, definitely, yes.
Yeah.
Like I stopped almost, but when I'm in Manila, I grow a lot of lettuce and other plants and arugula, and definitely my dill tastes way better than any dill you will buy in the market because it's just grown here.
Yeah. Yeah. Yeah.
Anyway, yep. Thank you very much for your time. Is there anything else I could have asked you? Or you want to share something else?
We've touched upon so many elements. I'm not sure. I think about maybe one final point, and we already discussed, but I think it's really important if we think about consumers and enabling the benefits of flexibility for them. The role of automation so vital. So it becomes a no risk and no brainer for consumers to be flexible. So we talked about 3 hours of free electricity. We talked about batteries in induction stoves, and we talked about less field. But automation is going to link all those devices. So it's not something that you as a user need to worry about on a daily basis. It's something that is going to happen. And that automation is also going to enable a whole range of tariff offers. So some of them, and that's something that I see emerging in Europe, that you get a fixed price for heating with a heat pump or a fixed price for charging your electric vehicle in exchange for letting this supplier automate the demand shift. And I think that's really interesting because it becomes something that you as consumer can see the immediate benefits of this lower priced electricity without having to worry about, do I need to change my schedule every day? No, it's just being automated. There's an app and it takes your preferences, whether that's AI or machine learning or something that you just type into. You can change that, you can override that, but you can be assured that you get this great deal. And I think that's really key, that we make it simple and we reap the benefits of electrification and automation and decarbonization.
Yeah, I had this. I have a home battery in my house in Melbourne. So I got an offer one day saying, if you sign up for this VPP plan, and we will only take for that many times in a year to meet the system demand, and we'll give you $500 in advance and every month X dollars. Okay, I signed up and I have not checked. So far, I see whenever they take the battery out, yeah, it's quite reasonable. And if I do that personally, maybe I can optimize, but is it worth my time? Maybe not. As you said, it's automated by a system and AI, some algorithm, and it creates societal value, and I'm getting a slice of that.
Yeah.
Excellent. Thank you so much again, Jaap. So let's keep connected and I'll come back to you. So many ideas.
It was great being on your podcast.
Thank you. See you. Bye-bye.
Thank you. Bye.
We hope you enjoyed this episode of Energypreneurs. To continue listening to this conversation, please visit us at Energypreneurs. Thank you. See you next time.